I'm Brady,
And I'm Andrew.
and this is our AI project that we did for the one Professor Lundy's AI class.
Indeed, indeed.
Um, what we did for our project is we created an AI that will solve a Rubik's Cube. Well, we have the start of it at least. Um, I originally got the idea to do this because Andrew was obsessed with a Rubik's Cube, an actual Rubik's Cube that he had, and thought it would be interesting to see if we could create an AI that could solve a Rubik's Cube.
Yeah,
Um, so,
that about sums that up. um, so the way we went about doing this, originally I had a bunch of cube face objects which had their own 3 by 3 arrays of characters. So that would sort of tell the program where the colors are. Uh, but the way I was doing that didn't actually work out. So what we have right now is a bit different. Um, as you can see, we have this list object called permutations, and we add a bunch of integer arrays to it. This is actually based on a aspect of abstract algebra that is called permutation groups. Um, so we have this list here. We have 5 lists for each individual cube face. So each cube face corresponds to like the top or the left or the front or etc. Um, and each of these permutations is used when we rotate the cube face clockwise. So for instance, we have these 5 lists for the white cube face, which is considered the top in our example. Every time it finds the element called 1, it brings the element to 3. And every time it finds 3, it brings it to 8, and 8 to 6, and 6 to 1, etc. So, essentially, to determine where things have to move, it will search through the giant array. It's an unfolded array, essentially, um, to find out where everything is. Then it will search through the list of permutations and find where everything needs to be, and then move them accordingly. So this updates correctly every time, which is why we ended up using it. Um, then we have a 3D representation of the cube, which, well, you can see it right here. You can just look at it. There are a bunch of different cube objects. So what you do to move it is you select your face. So when the player is using it, they click the center cube, and then when they decide to move it, the center cube then finds its exact center in space, and from that point it shoots out 8 rays to determine which of these cubes are adjacent to it. So it'll find all of those, and then it will parent those to the middle cube and then perform the rotation. So just a quick example of what the rotation looks like. I click on the blue face and hit the left arrow key to move it counterclockwise, and it moves counterclockwise. We also have a method to randomize it, which simply chooses like 100 random movements. So that gets it sufficiently random. And then in order to solve, we have this monstrosity of a method.
please hold all crying to the end of the method.
Indeed, indeed. So essentially it goes through and it looks for every single possible case that we would run into when trying to solve the top cross. And it has a prescribed list of movements for every case. So we're going to demo that in just a moment. Right now, the only thing that is solved is the top cross. But, that's okay.
Yeah, that was one of the big issues that we ran into is, um, this is such a large project and we only had so much time to do it. However, I think this is something that will be continued to be worked on until it can solve the entire cube.
Absolutely. And as you can see, it's hosted on my website, so I'll be posting a link that's a lot more readable in the description. So, for the demo, I'm just going to hit R to randomize. It's going to go through its 100 random movements. This was a big hit for our in-class presentation. Everybody was mesmerized. So now it's done randomizing, so I'll just hit S to have it solve the top cross. And there it is.
Done like that.
Nice and quickly. So the next stage would be to have it put each of the corner pieces where they belong. And then from there are actually algorithms that we can use to solve the next two layers. So hopefully it'll become a lot easier to finish this once the corners are done. But for now, yeah, we're proud of what we have.
Yeah, I mean, this is such a large project, and the amount of work that was put into this is crazy. I think next time we should stick to the maze idea.
Oh yeah. Yeah.
Um,
Mazes are much easier.
Yes. Also, that was another thing that was changed. When we first started doing this project, we thought genetic algorithms because, there are so many algorithms, that go into a Rubik's Cube that, it was kind of like, well, that must be the best solution. We realized very quickly that that was not the best solution.
Yeah.
So we decided to go with, is it case-based or rule-based?
Rule-based reasoning.
Rule-based.
Yeah.
So that is essentially what we have here. So pretty much the rule is solve the Rubik's Cube, and if it doesn't, it gets beaten.
Pretty
Not
much.
really. Yeah.
Pretty much. No, the rules are these extraordinarily complex instructions based on where it finds the cube it wants to move. So there are lots of rules.
It's like the world's strictest parents' household.
It's true. It's true. Well, anyway, I think that about concludes our video presentation.
Yep, and if you guys want to check this out for yourselves, solve a Rubik's Cube on your own, you can definitely check out the site. As Andrew said, it'll be posted in the description. We definitely suggest not using Chrome for it, though.
Yeah, Chrome and the Unity player don't really get along.
We have both run into issues with it, and we definitely suggest using Firefox if you would like to check out the Rubik's Cube. If you'd like to check out the site in general, Chrome is fine, but if you want to check out the Rubik's Cube, definitely use Firefox.
Yep.
So.
All right. Thank you very much for watching.
And I hope you all have a great summer.
Indeed. I know I will.